Hello friends, I have come with the epsilon delta definition of limit. If you love calculus, you can like this. Okay, let's start. Okay, then suppose we have a function of some real number f r to r, okay, defined by something. Then let in its domain we have a point some a. So a belongs to domain of f, which is equals to actually r. Then what is meant by this thing? Limit x tends to a, f of x equals to L. We all know, if we draw the graph first hand, suppose I consider a graph of f just like this, any graph, any monotone graph. Here f is monotone actually. This means f is just increasing, you can say. Somewhere not completely monotone, because somewhere it has just, in this point it has just little bit down, that means little bit decreased, but not quite monotone, but almost monotone. Maybe here is monotone, or we can get f dash a is 0, but look at this, there is the function is discontinuous. Okay, so I can make a bumper here which is a. So x equal to a, where we get, but we mean that from left hand side when x approaches a, and from right hand side when x approaches a, we get this here, some point of y L. So this is meant by this. But what is the epsilon delta definition of limits? So let's carry out this. Okay, so this is actually transformed into epsilon delta definition by this way. Okay, look at this way. Let for some, this is a definition. Okay, definition. Let for some delta positive, very tiny delta, okay, very small delta positive, we have some epsilon positive, or there exist some epsilon positive which is also very tiny here. Okay, then what can we say? Then now we can say that from this here we can write this in this way: f of x minus L, take a modulus, can be made less than this tiny very epsilon for all x minus a mod is less than delta. Okay, this, that means actually this, look at, delta is very small, then this means this is almost 0, or maybe this gap maybe decreased very much. So you get this here. For this here, look at, from the top it is just coming to L, and from the bottom is coming to L. That means this gap for any f of x minus L between, here is lots of point for lots of x, and here is lots of point for lots of f